Welcome to the second day of section 1-4. Now, what you're going to see is you're going to see a pattern emerge. What we did for segments, we're going to be doing for angles. So we had a segment addition postulate. Look what we have here. We have an angle addition postulate. So if point B is in the interior of angle AOC, so start at A, trace down to O, and you go over to C. So, and to be in the interior, it's got to be in this region. So B is in the interior of angle AOC. Then they're saying that the measure of angle AOB plus the measure of BOC has to equal the measure of angle AOC. All right, similar to segments. What we're saying is if we take this part and we add it to this part, that will come up with the whole angle. That would be the AOC. So again, basically, angle addition does for angles what segment addition did for segments. All right, here's our first example, and I think that you would agree that this is kind of intuitive. If this angle is 26 degrees and this angle is 37 degrees, then the measure of angle AOC must be the measure of AOB, which is 26 degrees, plus BOC, which is 37 degrees. So if you take these two angles and make a bigger angle, then their sum is going to be 63 degrees. That's what our angle addition postulate is telling us. All right, so maybe we should stay here. Maybe I should do another example. All right, so I've got this angle, and we'll call it WAY, and this can be an S. And suppose now I tell you that the measure of angle WAY is 120 degrees. Suppose I tell you that the measure of angle SAY is 40 degrees. I want you to find the measure of angle WAS. So what have we been given this time? We have been given that the whole entire big angle is 120. Now angle, say, S, trace it, AY, is 40 degrees. So if this whole big angle is 120 and this portion is 40, how are we going to get this angle? So we're going to take the whole, which is 120, subtract the 40 that we have, and we're going to end up with 80. So to check, my question to you is, if I were to take the sum of this angle, which is 80, and the sum of that angle, which is 40, and I add them together by angle addition, would indeed I get 120? I think you would agree. So you're going to get angle addition two ways. I'll either give you the parts and ask for the whole, like I did here, or I'll give you the whole and one part, and you have to find the other. So now we're going to do the similar, and now we're going to throw in the algebra. Measure of angle AOC. So put your pencil on AOC. All right, what this is telling me is it's telling me this great big angle is 3x plus 1. Well, what else is it telling me? Draw the diagram. Put this on your diagram. BOC. Well, let me get a different color. BOC is this angle, and they're telling us that is 3x minus 7. And I wrote a bad problem, because now I'm telling you that AOC is 120. All right. So what I'm going to do is I'm going to fix this problem. So we're going to say AOB is 3x plus 1. So now I just changed that. So what I'm going to do is I'm going to erase all of this. Okay, so here I go. So we've got measure of angle AOB. AOB is 3x plus 1. The measure of BOC is 3x minus 7. Now they're telling us that AOC, this big one, is 120 degrees. So what equation are you going to write in order to solve this? Well, we know if we take this part and add it to this part, it should equal the whole. So 3x plus 1 plus 3x minus 7 should equal 120. So we add the 3x's. Remember, you've got to simplify this side before you do anything else. 6x minus 6 equals 120. So you're going to add 6 to both sides. So we have 6x is equal to 126. We're going to divide both sides by 6, so x is equal to 21. Now, I didn't ask for x, I asked for the measure of COB. So in order to find the measure of angle COB, well, angle COB is COB. It's the same thing as BOC. That is 3x minus 7. Now, we're going to put our 21 in for x, so we're going to get 3 times 21 minus 7, which is 63 minus 7, which is 56 degrees. So make sure you don't stop at 21. Part plus part equals whole. Now, if we look at the next example, hopefully I wrote a better problem. Again, draw the picture. Get it labeled like it is. So now we're being told that angle JAB is 4x plus 1. We're being told that angle BAC is 7x plus 17. Those are the parts. Now we're being told that JAC, in other words, this whole great big angle, is 12x plus 5. So if we look at this, we've got 4x plus 1, and to that I'm going to add 7x plus 17, and that should equal the whole, which is 12x plus 5. Same concept, part plus part equals whole. So again, this is one side of your equation. You've got to combine like terms before you start to move things. So that's going to be 11x plus 18 is equal to 12x plus 5. I'm going to subtract 11x from both sides, at which point I'm going to end up with 18 equals x plus 5. Now to solve further, I'm going to subtract 5, and I'm going to have x is equal to 13. So what did they ask us to find? They asked us to find JAC. The measure of angle JAC happens to be 12x plus 5. So since I found my x, that's going to be 12 times 13 plus 5. And I don't know what 12 times 13 is. 6, 3, 2, 1. This is going to be 156 plus 5, or it is 161 degrees. Measure of angle JAC. So there's only two types where I give you the parts and the whole. You say part plus part equals whole. And I guess that's a concept that we need all year. So let me write that down. We've got part plus part equals a whole. That's a concept for all of those. All right, so now it's your turn. All right, so now JAC is a straight angle. What is the measure of a straight angle? That was in your notes yesterday. Go back to 14A, the notes you took yesterday, if you need to, because you need to know this information. All right, these notes right here are for the honors classes. They're doing proofs, we are not. All right, but what we are doing is we're going to construct an angle. So you're going to draw a segment on your paper and label the left end point A, prime. We're going to place another point on this segment and label it W prime. So at this point, you will have this ray done. All right? Then you're going to place a compass point on A, which is right here. That's the compass point. And using a size opening, any size opening, how's that? Draw an arc that intersects both rays. So it's going to look something like this. And I'll get a compass out and show you. Keeping the compass opening the same, place a compass point on A prime now. So here you're going to have this segment A prime, W prime, and the compass point goes here, and you're going to draw basically the same arc. And then on this point of intersection, then you're going to put your compass point here, your pencil point there, and you're going to measure that distance. So you're going to put your compass point here once you get that distance, and you're going to mark off an arc here so you know that that's where you're going to connect. All right, so you can't click there to see a video, so let me show you. I can't believe that I don't have an example. All right, so I'm going to go to a new page. I'm going to make us an angle. We've got this angle right here. We're going to duplicate. Let's call this angle AMY. So the first step is to construct a long ray. The second step is to grab ourselves a compass. There's my compass. So what we're going to do is we're going to put the compass point on vertex M. So over here they told us to label this M prime, and then there's some point over here Y. It doesn't matter where, as long as it's on that side. All right, now I'm going to open my compass, and my compass needs to be any opening. So I think I'm going to do that. So now what I'm going to do is I'm going to draw an arc, and the key thing is it must intersect both sides. So without changing the opening, I'm going to come down here. I'm going to put my compass point on M prime. And now I'm going to draw, oh, I just changed it. All right, so I've got to come back up here because I messed it up. All right, so now I'm going to move my compass point down here on M prime. And now I'm going to draw an arc. So these two arcs should be exactly the same. So now what we're going to do is we're going to put our compass point on this point of intersection. And we're going to open our compass. I'm going to need to tilt it a little bit. Takes some getting used to work with this. There. Compass point on this point of intersection. That was one of the reasons why we did it. We need this point of intersection. We need that point of intersection. So now our compass is this wide. Without changing its opening, come down here and put your compass point on the corresponding point, and now you're going to draw an arc. So what you've just done is you have just located that point right there. So now you're going to take your ruler and you can connect this vertex through that point of intersection. So now this angle, and somewhere along here we've got A prime. This angle is the same as that angle. That's how we get a congruent angle or duplicate an angle. All right, so we're going to construct an angle whose measure is twice that of J. So basically, we're going to be doing this construction 2 times. So I'm going to come here and I'm going to get my compass, and I'm going to come up here and I'm put the, remember we put the compass point on the vertex. We open this up to whatever opening we want, and we make an arc. Without changing my opening, I'm going to come down here, put my compass point here, because this corresponds to J. I can label this J prime. All right, let me move my compass point back where it belongs. And now we're going to do our pencil. Now notice I'm making a really large arc. Need a big one. Okay, notice I did not change that compass opening. So now we're going to come over here and we're going to measure. So I'm going to put my compass point on this point of intersection. We're going to put our pencil point on that point of intersection. Sorta. Is that working? All right. So now, do you see where it is? We're going to come down to the same spot here. Right there. And we're going to trace an arc. So what I have here, and I'm going to dot it because that's not my answer. What I have here basically is angle J. But I want 2 J's, so what I'm going to do is I'm going to take my compass, put my compass point on this point of intersection, and because I'm going to add to this, I'm going to take my pencil and I'm going to draw an arc there, so it intersects it again. So now I've got another line, and maybe I will do a solid one this time. So now this is going to go through that point of intersection, and my answer highlighted again, this is going to be 2J, because this is J and this is J, because we kept that opening the same. So that's twice an angle. So now we're going to construct an angle whose measure is the same as the measure of the sum of K and J. So what I'm going to do is I'm going to get this angle where we can work with it. I'll make another copy and bring it down where we can work it. So now we're going to add 2 angles. And we basically just added 2 angles, but it was based on the same one. So I'm going to start with my ray. And I'm going to grab my compass after I get my, okay. So I'm going to grab my compass, and I'm going to put my compass on let's see, there we go. Now I can use any opening I want. There, I'm going to use this opening. So now I'm going to intersect this 2 places without changing the opening. I'm going to come over here to this angle, and I'm going to construct a similar arc, making sure I intersect both sides. So important, without changing the opening. I'm going to come here and I'm going to make a really large arc. All right. So now we need to measure. So I'm going to put my compass point here, and I'm going to put my pencil point somewhere around there. And I need to get it better. I tell you, it's so much easier to work with a compass than this. All right. So now I'm going to come down here to this point of intersection, and I'm going to draw an arc. That is angle J. So now I'm going to come up and put my compass point here. Let me get this different. So I'm going to put my compass point on this point of intersection. I'm going to adjust my compass so that it is that wide. Hold on, I've got to make sure, yep. So my pencil point is there, so that's that opening. Without moving, without changing that opening, I'm going to go to the end of my first angle that I just made here, that point of intersection, and I'm going to draw another arc. So when I connect this point with that, I've got this angle J. Oh, this is angle J. This is angle K, and that angle is the sum. So I would highlight my answer, and it would look something like, oh, this. That didn't work very well, did it? All right. So now we're going to subtract an angle. We want to take the difference of K and J. Difference means I have to duplicate K, and from K I'm going to remove J. So on our new slide, I'm going to get another protractor. I should say compass. I'm going to put the compass point on the vertex. That's where we start when we duplicate angles. I'm going to open this up. I'm going to draw an arc. Leaving the opening the same, I am going to put my compass point on J and make another arc. Leaving my opening the same, I'm coming down to the end point of my ray, and I'm going to make a nice large arc. Now, we want to start with K. Let me get this out here. All right. So now what I need to do is I need to measure the opening of K. So there's that point, and this point I'm going to need to rotate a little bit. So that's on that point of intersection, and I need to rotate it a little bit more. So rotate it a little bit more. There we go. So I've got it. So now I'm going to come down here to this point right there, and I'm going to make an arc. Now this is angle K. This is angle K. From here to here is angle K. So now I'm going to take my compass, and I'm going to come up here, and I'm going to put my compass point on this point of intersection, and I'm going to adjust this. You should be glad you're not working on the computer. Hold on. We need to rotate it a little bit more. All right. So I put it on this compass, on this point of intersection, and now I've got my opening. So now, if I'm adding, I come here and I go beyond the angle, but since I am subtracting, then I want to remove this from the angle. So basically, if I were to draw this in, this is J right here. This is J. From here to here was K. So K minus J is going to be this angle. And we're not doing proofs. There you go. So what I've asked you to do is using a protractor. This gives you practice on the protractor. You're going to draw a 15-degree angle on your paper, and let's label it angle and name it A. I already told you, good. Then you're going to draw a 30-degree angle on your paper, and you're going to name it B. And so now what you're going to do is you're going to construct an angle C that's 5 times the measure A. That means you're going to do five of these. You're going to have a segment, you're going to have an arc, and then you're going to mark off 1, 2, 3, 4, 5. And then you're going to add 30 to that, and hopefully that's going to work. Yeah, that will fit. All right, this is not us. This is honors. And I think I just did the wrong thing. No. This is going to be deleted. And it looks like we're finished. So that is how you construct angles. All right, if you want to see a different video, then what I'm going to do is I'm going to click here. I'm going to move that out of the way. I'm going to click here, and this takes you to a page which has how to construct the angles. And I'm going to copy this. I'm going to go back to our notes, and I'm going to paste it. So if you want to watch this video, watch someone else do it, then go to that website and it will work.